Alrighty guys, so in the previous video we learned a skill on how to basically add and subtract fractions. Also we did sort of a sample one of how to take the derivative of a rational expression. In this video my plan is to work on this problem and one more so that we sort of practice on that skill and we get really good, so that once we're presented with some independent practice we're able to do that on our own pretty good or pretty well. So let's just get started, okay? Here we have this function f of x equals 1 over x plus 5, and we want to basically find the instantaneous rate of change of the function at a, and a coincidentally happens to be 5. So we want to find that derivative at 5, the instantaneous rate of change at 5. Very first step is write your definition of your derivative. So the derivative of x is going to be the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, we know what f of x is. We don't know what f of x plus h is. So let's evaluate that. F of x plus h is going to be 1 over x plus h plus 5. Okay, let's rewrite that and get rid of that parentheses. F of x plus h equals 1 over x plus h plus 5. Alright, so now we know what our f of x plus h is. We just plug it into our formula now. So we say, okay, the limit as h approaches 0 of 1 over x plus h plus 5, okay, minus the original, which is 1 over x plus 5, okay, and instead of dividing by h, we're going to be multiplying by 1 over h, which is exactly the same thing, okay, so 1 over h. Okay, what did we learn previously? All we did was we have this denominator here, we're gonna put it here. We have this other denominator, we're gonna put it here, and in the end our resulting denominator is going to be a multiplication of those two. So let's do that. Okay, so we have the limit as h approaches 0 of x plus 5 minus x plus h plus 5 over the multiplication of those, so x plus h plus 5, x plus 5, erase this, okay, and then all of this is going to be multiplied by 1 over h, okay, so let's see what we can eliminate. We're obviously going to eliminate this x and this x. We're also going to eliminate this 5 and this 5, and we're going to be left with that h term. So the limit as h approaches 0 of negative h over x plus h plus 5, x plus 5, and all of this is going to be multiplied by h. You can see that this h eliminates or goes away because it's both at the numerator and the denominator, so it goes away. And so you're going to be left with this. The limit as h approaches 0 of negative 1 over x plus h plus 5, x plus 5. Okay, and so what happens is h approaches 0, this goes away. So in the end you're going to say f prime of x is going to be negative 1 over x plus 5, x plus 5, which is nothing but negative 1 over, I don't know what's wrong with my right and my screen, x plus 5 squared. All right. So that wasn't so bad. Let's do one more, and then after that, if you have further questions, make sure you post them on the YouTube comments or send me a private message on Google Classroom. Okay, so here our function is going to be f of t. We're going to say f of t equals 1 over t squared, and we want to find the derivative of that function at 2. So what do? We simply write our definition of the derivative. So this time, notice how our dependent variable is t and not x. So you're going to say the limit as h approaches 0 of f of t plus h minus f of t over h. Okay? And do we know what f of t is? Yes, we do. We do not know what f of t plus h is. So let's evaluate that. F of t plus h is going to be 1 over t plus h squared, which incidentally, if you expand, is going to be 1 over t squared plus 2th plus h squared. Okay, so now we know what that f of t plus h is. Knowing that, let's go ahead and plug that into our definition of the derivative. So the limit as h approaches 0 of, what's my f of t plus h is 1 over t squared plus 2th plus h squared, okay, minus 1 over t squared, and all of this is going to be multiplied by 1 over h, which is the same thing as dividing it by h. Alright, so now, okay, we have two different denominators, so we're going to grab this denominator and we're going to put it here. Going to grab this denominator and put it here, all of it. Alright, and then our new denominator is going to be the product of those two. Alright, so let's get started on that. So the limit as h approaches 0 of t squared minus t squared plus 2th plus h squared, okay, over the product of those two, so that's going to be t squared plus 2th plus h squared times t squared, and all of this is going to be over 1 over h. Alright, so now let's eliminate some terms. The only thing you're going to be able to eliminate here is this t squared and nothing else. Alright, so that's a bummer for that, but at the end we're going to be able to get rid of some h's. The limit as h approaches 0 of negative 2th minus h squared over t squared plus 2th plus h squared t squared, okay, and all of this over 1 over h. Okay, now you see some h's at the top and there's one h at the bottom, so let's eliminate that h right here. We eliminate this squared and we eliminate this one. Okay, and now we plug in our value of h at 0 because we're taking the limit as h approaches 0. So let's write it, the limit as h approaches 0 of negative 2t minus h. Remember, the squared term was taken away and the h in front of the 2t was also taken away. And so we're left with t squared plus 2th plus h squared times t squared. Okay, plug in the h equals 0, so this goes away, this goes away, this goes away. Okay, those terms basically, go away. And now we're left with the derivative, which is going to be equal to negative 2t
over t squared, which is nothing but negative 2t over t squared. Okay? If we wanted to find that derivative at 2, so f prime of 2, just simply plug in 2 for t. So we're going to get negative 4 over 16. So that's going to be f prime of 2 is going to be negative 1/4. Okay. Alright, so today's assignment is actually very tricky, and you have to be able to have patience and basically look for little patterns, little shortcuts that you can use. Make sure you eliminate terms. Today is all about eliminating terms and being able to find those with accuracy. Okay, so good luck, and I hope that this video is helpful to you. If you have any further questions, again, pose them. Don't be shy. I'll be able to help you.